It should be working now. One second. Let me just. Okay. All right. So today I'm going to go over something. It's something that's pretty useful in geometry questions, depending on like the configuration. And it's going to be called. Why am I still getting notifications? Okay, it's called mass points. Okay, why am I getting so many notifications? 1 second. Okay, whatever. So what mass points basically is it helps you find ratios of lengths within a triangle and its cVns. So first, we're gonna do something that's not like really related to geometry, but it's like the basis of this technique. So first, if we let's just consider like a scale with two sides, like that, with a fulcrum in the middle. So if we place a weight with, let's say its mass, we place a weight here, and we say its mass is equal to m, and its distance away is equal to d. Then our question is, if we have a mass, if we have another mass of like 3m, so basically it's 3 times as heavy as our initial mass, where should we put the mass in order for it to balance out the scale? So now we just use our formula. Well, I'll introduce something. In order to balance it, you need the distance. Like the distance of the first mass times the distance of the times the mass is equal to the distance of the second mass times the mass of the second mass. So we know that the first mass has a mass of m and has a distance of d. The second mass has a mass of 3m. And we're trying to find d2, which is its distance away from the center. So if we just divide both sides by m, we'll find that d2 is equal to d over 3. So basically, our second mass has to be 1/3 the distance of the first mass in order to balance out our balance beam here. You can also just notice that it's inversely proportional. So like if a mass is like 3 times as heavy, its distance is 3 times as small from the center. Okay, so that's the introduction of something that we see in real life, which is like balance beams. So now we're going to relate this to like something that we would see on like an AMC contest or something. So pretend like if we're given a triangle. And let's call it ABC. Okay. So we draw points like E is on AC such that with CE is equal to 3 times AE. So EE is going to be like about here. And it has a ratio of 3 to 1 here. The distance ratio is 3 to 1. And then it tells us F is on AB. Sorry, someone at the door. All right, F is on AB such that BF is equal to 3 times AF. So basically F is going to be somewhere here with a 1:3 ratio. Is no one getting that? Sorry, there's someone at the door. I'm going to be right back. I don't know where my parents are. All right, I'm so sorry about that. Like, my parents didn't want to get the door or something. All right, so I'm going to continue. So the question says that BE and CF intersect at O. And then AO intersects BC at D. So BE intersects CF at O. Then AO intersects BC at D. So with math points, we can easily calculate ratios like OB over OE, or we can calculate ratios like OD over OA. And the way we can do that is we can basically assign masses to each of our points so that we can have them to balance out. So let's just start off with C. Oh, if we assign it with a mass of 1, let's consider our balance beam of A, E, and C. So in order to balance this beam, we would need a 3 on the other side. We need A to have a mass of 3 because we need the distance times the mass to be constant. So we need the 1 times 3 equals 3 times 1. And then similarly, B is going to have a mass of 1 as well because 1 times 3 is like these two multiplied need to be these two multiplied. And then on the balancing point, we sum up both of the masses on each side. So this will be a 4, and this will be a 4. This will be a 2. So let's find OB divided by BE. So we want OB. Let me switch colors. So we want this OB divided by OE. Right. But we realize that B has a mass of 1 and E has a mass of 4. So in order to balance out this balance right here, we would need OE to have a distance of 1 and then OB to have a distance of 4 to 1. So this answer is going to be 4. And then for something like OD divided by OA, we realize that D has a mass of 2 and then A has a mass of 3. So basically the distance are going to have you just switch the two numbers. So the distance ratio is going to be 2 to 3. So this ratio is going to be 3 over 2. And this is just like some question that I made up. It's not really a contest question, but if you want to see example that was used in a recent contest, a good one would be one actually appeared like 2019 AMC 8. And this was actually a number 24. So some of you guys might have actually saw this question when you were taking the exam. So what it basically says is, in a triangle ABC, it tells you that point D divides AC. D is on AC, such that AD the ratio of AD to DC is equal to 1 to 2. So basically D is somewhere here, with AD to DC is 1 to 2. And then tells you E is the midpoint of BD. So let's draw BD here. And E is going to be our midpoint. So midpoint is basically means that the two sides are equal. And then it tells us F is the intersection of BC and AE. So it's basically
it's unlimited. Cool. It's unlimited. You can die.
okay, never mind. I'll continue. And then it tells us that the area of triangle ABC is equal to 360. And the question asks, what is the area of triangle EBF? So it's asking us for like this area here. There you go. And if you just use mass points to find some of the ratios, like I did above, and you use some like ratios, you could probably find the area. So I'll give you guys a few minutes to try that out. Okay, has anyone gotten any progress yet? Okay, oh well, I'll just start going with the solution then. So once again, we just start by assigning a mass to any point in the triangle. So let's just say, it doesn't matter really, but let's just say we start with C, and we assign it with the mass of 1. So we know that the mass times the distance has to equal the mass times the distance here. So we can assign a mass of 2 on the vertex of A. So we know the mass on the vertex of D is going to be the sum of A and C. So this mass is going to be a 3. And then since this is a 1-to-1 ratio, we know that B also has a mass of 3. And therefore, E has a mass of 6, because it's the sum of B and D. And then now we know that F also has a mass of 4. We can find this 2 ways. It can be 3 plus 1, or it can be like 6 minus 2 on this line. So now we can find some like really useful ratios. such that like FC over, let me mark these for you. So like this FC divided by FB is going to be 3 to 1 from the corresponding masses. And we can use that to find stuff like AE over EF. So we can find that to be 4 to 2, which is the same thing as 2 to 1. And then we can just start using our ratios and then converting them into area conditions. So for example, if we find area of ABF, triangle ABF, divided by area divided by area of triangle ABC. This is just equal to the side length of BF over BC, which is just equal to 1 divided by 4. And since the area of ABC is 360, we know that the area of triangle ABF is going to be 90. And after we find the area of ABF, we can find the area of EBF now, because we can use the same exact ratios. We can use the area of triangle EBF over the area of triangle ABF is just equal to EF over AF, because we can just compare their bases because they have the same height, which is equal to EF over AF is exactly 2 over 6, which is equal to 1 over 3. And since we know that the area of ABF is 90, we know that the area of triangle EBF is equal to 90 over 3, which is just 30. And that's our answer. So you can see that we relatively quickly solved this number 24 on like an AMC 80 using this method. Does anyone have any questions? Oh, I was just going over this technique. It's called Mathcounts, but I don't want to have to like go over it again. So we're gonna post the recording on YouTube, and you can watch it later to get a better understanding. Okay. All right. So if there's no questions, I guess I'll just move on to the live solve section. So I'll just like choose the AMC to do as always, and then we'll just do it in the time limit, I guess. Let me just stop recording on this thing. All right. I'll screen share on my computer. Wait, actually, I'm not good with Zoom. I'm being told that I can. Let me check something. Wait, how do I? Wait 1 sec. I'm gonna convert to I'm gonna use my computer because my iPad's not working. All right. Okay. Oh yeah. So this is the question I was talking about. This was this year's AMC. Well, I mean last year's technically. Okay, so you guys can go over like, so which year do you want me to do right now? Yeah, I can do any year basically. And then I'll just solve it live. 2009. Does anyone else want to say a year? If not, I'll just do 2009. All right, 2009 it is, I guess. Yeah, let me just see. How do you? Okay, do you guys want me to start from like problem 1 to 25, or should I go backwards? Or should I just go in like a random order? Okay, Edward. Wait, I really just got one. All right, we'll just do one then. I'm pretty sure you guys can all handle this question. Bridget bought a bag of apples from the grocery store. She gave half the apples to Anne, and she gave 3 apples to Cassie, keeping 4 for herself. How many did she buy? Okay, so I mean it's 14. So basically, she has 7 total after giving half of her apples away. So she has a total of 14. Yeah, good job. All right, let's see which one should I do next. Number 11. Okay, so 2 spinners are spun once, and each lands on one of the numbered sectors. What is the probability the sum of the 2 sectors is prime? Okay, so basically this one is just kind of casework. So what we do is like we consider all 9 possibilities. There's 9 possibilities here. So the first one, the first spinner, let's call it spinner 1. Wait, how do you? Okay, let's call this one spinner 1. Ew, what is this color? All right, and call this spinner 2. So for spinner 1, we have 3 options, which is 1, 3, and 5, which are equally likely. And then they can all have 3 different options, which is 2, 4, and 6. 2, 4, and 6. 2, 4, and 6. And then now we can basically just evaluate the sum for each of these cases. So for this case, the sum would be 3. This one, the sum would be 5. This one would be 7. This one will be 5. This one will be 7. And this one will be 9. This one's 7, 9, and 11. So basically, we just we want the probability that the sum of the numbers is prime. So our prime numbers are going to be 3, 5, 7, 5, 7, not 9, and 11. So you realize there's 7 numbers that's prime, and there's 9 numbers, 9 total combinations that are equally likely. So our answer is going to be D. Are there any questions on how I got that? There. Oh shoot, what did I do? I just closed the tab. I'm stupid. All right. My bad. I gotta wait for, okay. Okay. So now we clear all. Okay. Let's go to our next question. Okay, number 5. We're getting some easy ones. So it says a sequence of numbers starts with 1, 2, and 3. And it says the fourth number in the sequence is the sum of the previous 3 in the sequence. And then it says every fourth number is the sum of the previous 3. So this one's just kind of a bash. We just like calculate all the sequence. So it says every number is the sum of the previous 3 numbers. So if we have 1 is our first number, 2 is our second number, and 3 is our third number. We know our fourth number is going to be 6 because it's 1 plus 2 plus 3. And then we find the next term is 11, 20, hopefully I don't screw up, 17, 37. And then our eighth term is going to be these 3 combined, 48, so it's going to be 68. D. Okay, that one was pretty basic. Oh yeah, all these questions are from AOPS, which is a really useful site. Number 10. All right. So it says, on a checkerboard composed of 64 unit squares, what is the probability that a randomly chosen unit square does not touch the outer edge of the board? Okay, so we want to count the number of unit squares that do not touch the outer board. So I'll first mark which squares touch the outer board. So like these squares on the edge are all bad. We don't want these because these do touch the outer square. So what we want to do is we actually want to count. Why are there so many boxes being made? Okay, so we actually want to count these, like the number of squares in the inside. Wait, who's making those? How do you stop other people from making stuff? Okay, they're gone now. All right, so we actually want to count like the number of squares inside here. There. So we realized that the inside is actually a 6 by 6 square. So there's a total of 36 good squares. And then the total number of squares is 64. So we simplify this to 9 over 16, which is D again. All right. Are there any questions on this one? All right, if not, we're gonna go to the next one then. Okay, these questions are all like, I'm getting low numbers. All right. Ooh, okay. So 5 pieces shown can be arranged to form 4 of the 5 figures. Which figure cannot be formed? All right, let's see. 5. So let's just go through each of them one by one. So let's try and find something for A. So we find this one looks pretty long, so we'll just say this one's a 5, and this one's a 3, this one's a 2, this one's a 4, and this one's a 1. So A can be formed. Let's go to B. Obviously, you can't put a 5. You can't put a 5 in a row anywhere inside B. So B cannot be formed. But like just in case, we can go through all of the other 3 cases to make sure that they can be constructed. So this one obviously can. This one, 5, 4, 3, 2, 1 can be formed. And 5, 4, 3, 2, 1. So obviously B is the only one that can't be formed. Alrighty. Let's see which one is next. Number 5, really? Oh, we already did number 5. Okay, there you go, 13. A bit higher. So it says a 3-digit integer contains one of each of the digits 1, 3, and 5. What's the probability that the integer is divisible by 5? This is just another one of those questions where we look at each possible 3-digit number, and then we're going to see how many are divisible by 5. So you notice there's 6 of the numbers, so it can be 1, 3, 5, 1, 5, 3, 3, 1, 5, 3, 5, 1, and 5, 1, 3, and 5, 3, 1. So let's see. These are the only 3-digit numbers because there's 6 permutations in total. So I ask you, what's the probability that the integer is divisible by 5? It's divisible by 5 if its last digit is 5. So this has a last digit of 5, and this one has a last digit of 5. So there's 2 numbers, and the total numbers is 6. So the probability is going to be 1 over 3. All right, everyone gets that, right? Okay, let's do the next one. Number 12. Oh, I'm getting so many repeats. Number 10, yeah, I did that one. Dude, what's wrong with this RNG? I'm getting like all repeats. There you go. Okay, number 19. 2 angles of an isosceles triangle measures 70 and x. What is the sum of the 3 possible values of x? Okay. So basically, in an isosceles triangle, I have a draw line feature. That's going to be useful. There you go. So in an isosceles triangle, we have that two of the sides are equal to each other. So which means that 2 of its angles are equal. So like these 2 angles are equal. And we also, so let's call these angles, so it says the angles are either 70 or x. So let's say one of these angles were 70. So this one would also have to be 70. So if this was x, we know that the sum of the 3 angles is 180. So x would be equal to 180 minus 140. So 40 is one of the possible answers. So it's one of the 3. The problem tells us there's 3, so we should try and find 3. Okay, the second possibility Second possibility is if this top angle is 70. And then this angle is x. And this angle is also x. So then we get 180 minus 70 is equal to 2x. So therefore we get x is equal to 55. So that's our second possibility. And you might be thinking, where's the third one? Well, in this case, x could, like 70 could be this angle, and then x could be this angle. So the third possibility is going to be x is equal to 70. I think. Hopefully I didn't screw this up. So if we sum this up, we'll get 40 plus 70 is 110. 110 plus 55, and that's going to give us D. Does anyone have any questions on this question? All right. I don't think anyone has any questions, so I'll just go into the next one. All right. Ooh, okay, 24.
No, I'm not. Okay.
Okay, whatever. I'll just continue. So it says, so this is like more of a puzzle question. If the letters A, B, C, and D represent digits. Okay, so this is like a puzzle question, I guess. So it tells us that, so we have to look at it like one piece at a time. So if we look at this column right here, we get that B plus A is equal to A.
I've teamed up with, hey, I'm Rick. I've been a game designer for more than 13.
Can you mute yourself, please? Thank you. All right. So from this column, we get B plus A is equal to A. So we deduce that B is equal to 0. That's what we get. And then now if we look at this column, we get B minus A is equal to A. And if we notice, that means that A has to be 5. Because like when we carry, like I don't know how you guys do subtraction, but you would put a -1 and B is 0. So it'll be 10 minus A is equal to A. So that means A would be equal to 5. And then now we have to look at our third and fourth columns, basically. So we look at this thing. So we already know that A is equal to 5 and B is equal to 0. So we have that 50 minus C5 is equal to 5. So obviously we have this is equal to 45, so C is equal to 4. And then now we can just plug it in here. AB is 50, CA is 45. So the sum is going to be 95, and the digit D is going to represent 9. Yep, that was like, if you just notice to look at the small details, it's not that hard. I'm pretty sure you guys can solve this. It's not that bad for a 24. Oh, okay. So someone wants me to re-explain it. One second, let me. Wait, someone's okay. One sec. Okay, someone wants me to re-explain number 4. So I guess I'll just go over it quickly again. Something more detail. So from this column, how do you find the numbers? Questions, how do you find the numbers? Yeah, so we have to use some properties of the sum to deduce each number. So if we have b plus a is equal to a, from here, we know that b has to equal to 0. So that's what we deduce. From the second column, we have b minus a is equal to a. But since b is 0, we know we have to carry a 1. So it's going to be 10 minus a is equal to a. Right here, 10 minus a is equal to a. So we have a is equal to 5. And then slowly and surely, we can just deduce every single number here. Because from 50 minus CA is equal to 5. We know C is equal to 4. And then from C is equal to 4 here, and then A is equal to 5, we deduce that D is equal to 9. Hopefully that clears it up. Okay, sorry about that. We're going to go to the next question now. RNG number 2. Alrighty. This one, you guys should be able to comfortably solve like these questions. On average, for every 4 sports cars sold at a local dealership, 7 sedans are sold. The dealership predicts that the next 28 sports cars will sell 28 sports cars next month. How many sedans does it expect to sell? I cannot talk. All right. So this is just a basic proportions question. You guys should learn this in school. So 4 sports cars over 7 sedans. That's the ratio. So if it sells 28 sports cars, what we do is we cross multiply and we divide to find the proportion. So we find that this is actually 49 sedans. Yep, D. That should be a basic question. Alrighty. Next question. Hopefully you get a harder one. Yay, 22. Okay. So it says, this one's a short question. How many whole numbers between 1 and 1,000 do not contain the digit 1? Oh, so basically, if you know how to do these types of questions, you should be able to do it within like 30 seconds. Don't be scared that a question is placed like number 22. A lot of these questions have simple tricks that once you know, they're pretty easy. So if we look at the whole numbers, it's a 3-digit number. Oh, whole numbers. Okay, so it doesn't have to be a 3-digit number. It can be any digits. So if we look at each digit, they can be from, wait, let me just read this again. Okay, yeah. So this one, all 3 digits can be 0 to 9. Except, well, actually not 0 to 9. They can be, each of these digits can be 0, 2, 3, 4, ... 9. Because they can't be 1. They cannot be 1. It cannot contain the digit 1. Is it real? All right. So basically, there's a total of 9 digits here. 0 to 9 minus 1 is 9 digits. So there can be 9 digits here, 9 digits here, 9 digits here. So if we multiply them all up, we get the answer of 729. But we notice that 729 isn't one of these answer choices. And that's because we're counting the numbers 0 0, 0. And that's not in between 1 and 1000. So that doesn't count as a whole number. So we have to subtract 1 for the case of 0, 0, 0. And then we get 728, which is going to be D. So like if you accidentally missed a special case of 0, 0, 0, the good thing about these contests is it's multiple choice. So you can see that none of the answers match if you get 729. So then you can just remember to subtract 1 from your answer. Alrighty. Let's do our next question. 7. Have we done that one? No, we have not. All right. The triangular plot of ACD lies between Aspen Road, Brown Road, and a railroad. Main Street runs east to west, and the railroad runs north and south. The numbers of the diagram indicate distance in miles. The width of the track can be ignored. How many square miles? Okay, so all it's trying to do is it's just trying to tell us to find the area of this shaded triangle. I'm pretty sure all you guys know how to do that. Remember, as a hint, this can be our base. And then this will be our height. So this is H, and this is B. So we know that the area from the formula is simply base times height over 2, which is just equal to 9 over 2, which is going to be our answer of C. All right, so that one was just like, that one was just a basic use of our area formula. Number is 16. Oh wait, David said one, the previous question was D. This one? Yeah, it's D. Okay, I don't know. All right, we're doing number 16. How many 3-digit integers have digits whose product is equal to 24? So this one's just more of like those casework questions. So let's just find all the possibilities of 3 numbers that multiply to 24. So we can have stuff like, there's so many combinations. So if one of them is a 1, then we can have like 3 and 8. We can have 1, 4, and 6. And those are only 2 possibilities. If we have a 2, the rest need to multiply to 12, so we can have 2 and 6. There should not be a comma here. Okay. We can have 2, 3, 4. And I'm pretty sure that's it. And then we can have stuff like, yeah, I'm pretty sure those are the only combinations, if I'm not mistaken. And realize that each of these numbers, so like 138 has 6 permutations. 146 has 6 permutations. 234 has 6 permutations. And this one only has 3 permutations. So when I say permutations, I mean how many ways can you arrange it. 138, I can arrange it 6 different ways, but 226, I can only arrange it 3 ways. So if we sum up these 4 numbers, we get D, 21. Does everyone get all the steps I did? Oh, okay, so some people have questions, so I'll just go more detailed, I guess. So we just want to find all 3-digit integers that has a product equal to 24. So we see that like 138, the product is 24, 146, 226, and 234. We can check that these are the only possible ways of 3 numbers. Yeah, we just want to find 3 numbers that multiply to 24. Because the question asks us the 3 digits has the product equal to 24. So like 1 times 3 times 8 is 24. 1 times 4 times 6 is 24. And then 2 times 3 times 4 is 24. Oh, these aren't fractions. Okay, so what these are the permutations. We call these permutations. We should have taught this a while ago, but I'm not sure. I think we were supposed to. So a permutation of like 138 would be just any way to rearrange it. So like 183 is a permutation. And then like 318 is a permutation. 381 is a permutation. 813 is a permutation, and 831 is a permutation. So we have this number can form 6 different 3-digit numbers, or it's called 6 permutations. Similarly, we see that 146 also has 6 permutations. And then 234 also has 6 permutations. But if we look at the number 226, it only has 3 permutations because it can be 262 and 622. These are the 3 permutations. We don't have any other permutations. And we want to find all of the 3-digit numbers. Hopefully that makes sense. Okay, so I think we have time for like 1 or 2 more, depending on which numbers I roll. Oh, okay, so maybe 2 more because I got 3. Okay, so this question says, the graph shows the constant rate of Susanna riding her bike. If she rides a total of half an hour at the same speed, how many miles will she have ridden? So they give us a minute versus miles. So if we look at these points, let me draw it. We see that the ratio is approximately, it's not exact, but it's approximately 1 mile per 5 minutes. So if she rides for half an hour, which is 30 minutes, she rides about 6 miles. So our answer is going to be C, 6 miles. That one is also like a pretty easy proportion question. And I think we have time for 1 more. Hopefully we don't get a hard one. Okay, number 15, that's medium hard. Ooh, some fractions. A recipe that makes 5 servings of hot chocolate requires 2 squares of chocolate. So it just requires all these ingredients. Okay, so what's the greatest number of servings of hot chocolate they can make? So 5 squares of chocolate over 2 squares per 5 servings. So in this case, she can serve 25 over 2 servings. But if we look at her water, she only has 2 cups of water compared to 1 cup in the recipe. So she can only make 10 servings. And then if we look at the milk, she has 7 cups of milk compared to 4 in the servings. And if we multiply this by 5 servings, we'll get 35 over 4 servings, which is, if we convert it to mixed number, it's going to be 8 and 3/4 servings. So if we look at the least number here, the least number is going to be this one. So the greatest number of servings she can make is going to be D. Okay, that's going to be it. If you guys ever have any questions on like these AMC questions, they always have like great solutions, or you can just email us and we'll be there to answer. I'm pretty sure that's going to be it for today. And good night, guys.
Bye everyone. Stay safe.